Well, hello, mathematicians, and welcome back. We're covering Guided Practice 8.2 in Course 1 of Math and Focus. And so today we're going to be looking at Guided Practice 6, 7, 8, and 9. And there are some errors in the teacher's manuals. We're going to go over that. So in this problem, number 6, the width of a rectangular tank is 2 meters less than its length. So let's go ahead and just draw a visual here to get us going. And it doesn't have to be perfect. It just has to kind of serve its purpose, right? So this is the length. That's from side to side in the front here. That's the length. And this is the width. Okay. And we're told that the width is 2 meters less than the length. So I'm going to write that down. And then we're also given some more information that just is going to make our life just a slight bit more complicated. And that's that the length is p meters, okay? We're calling the length also p. And so I'm just going to put a p there to help myself remember it. And then the width, we're calling q meters. Okay, so I'm just going to rewrite that to show our equation. And the equation is q equals p minus 2. All right. Well, very good. How do I figure out what is the dependent variable and what is the independent variable? Well, I asked myself this question. Which variable needs the other one in order to find the value as the problem is written? All right, so could you rearrange this problem and say, well, p equals q plus 2? Yes, you could, but that's not the problem. The problem is q, or the equation is q equals p minus 2. So as written, which value does the equation need to have in order to find the other one? So which variable needs the other one? And here we see that q needs the value for p in order for us to find it, right? And since q needs p, then q is the dependent variable and p is the independent variable. And you see over here that that is exactly opposite of what's been written. So we're going to rewrite this. This is p. This axis is p because q needs p. And that means this axis is q, right? So although the teacher's manual did have the correct solution, it did not have it labeled correctly. And you see that I have relabeled it. I've moved the labels around so that the length is on the x-axis. All right, so here we go. Now we have to figure out what is the width so that we can plot some of these points. Well, we know that if the length here, p, is 3, then the width here is going to be 1, okay? So we're just going to subtract 2 in order to find what it is. So they've already done that on this first bit of data. And the second one, if the length is 4, 4 minus 2 is 2. So I'm going to put a 2 here over this question mark. That's that blank. If the length is 5, well, then I can tell that the width is 3. If the length is 6, well, subtract 2 and you get 4. That one's done. And then if it's 7, subtract 2, we get 5. So if the length is 7, the width is 5. And if the length is 8, the width is going to be 6. Just going to subtract 2. So we see that finding the width is dependent on finding what the value, or knowing what the value of the length is. Right, now that this is set in our minds, let's go ahead and graph it, right? So we've said that the width, knowing the width, depends on the length. That means that we can choose to represent this so that the length, p meters, is our x-axis, right? So this is x, and this is the equivalent of y, right? X being the independent variable, right? And y being the dependent variable. In this case, the independent variable being p for length, and the dependent variable being w for width, or cube for width rather. Okay, so then I'm going to just, now that I know which is which, I'm just going to go ahead and plot it. So my first pair is 3, 1, right? So I go over on the x-axis to 3, and then I go up to 1, right? And I'm going to put a plot mark right there. And then the next one, I see this ordered pair. It's called 4, 2. Okay, I'm going to go over to 4, and I'm going to go up to 2. And that's where my next plot is going to be. Okay, and so then the next one, of course, 5 and 3, go over to 5 and up to 3. Oops, right there. Oh, and now I see how the line is really shaping up. The next one was given to me, and that's 6, 4. So over on to 6 on the x-axis and up to 4. There's another plot. And then for the next one, over to 7. Here we are at 7, and we're going to go up to 5, right? And then lastly, over to 8 and up to 6. At this point, you can draw your line, although it's very clear to see that all your points are connected there. All right, so that's the line. And the last problem says, well, look, there's a point on this line, which is 5, 5, and 5.5 and 3.5. So let me do this in a different color so you can see it more clearly. Here's 5.5. This is 5.5. And so if I go up to the line, you see that I hit it at 3.5. Okay, now is 3.5 2 less than 5.5? Well, sure it is. 5.5 minus 2 is 3.5. So this is a valid point on the line. The question is it a valid solution for our problem? Could I have a rectangular tank that was 5.5 inches in length and 3.5 inches in width? And the answer is, of course, I could. They can make tanks any size, any specification, and so that point is a reasonably acceptable answer. Now, are there instances where a half of an answer or a half of a value would not be acceptable? Sure. You can't have half of a sweater if you're going to get dressed, or half of a pair of trousers, or, you know, I don't know, you wouldn't package a bag of fruit with half of a piece of fruit necessarily. So there are some situations in which you would not use the half value. It would not make sense in this situation. But to build a tank, sure, you can have half values. All right, well, let's go ahead and go on to problems 7 and 8. So Paul and Lee went to the library to borrow some books. Paul borrowed 6 more books than Lee. Okay, so let me do this with a different color. Go back to the dark color. Paul's is Lee's books plus 6. Okay, so that shows us that Paul borrowed 6 more books than Lee. Now, we are told that we're going to change that variable. We're to use x and y. Well, in order to figure out what is what, then we need to ask ourselves which variable needs the other one. And we see that in order to solve for how many books Paul borrowed, we need to find out how many Lee borrowed, because Paul's is dependent on Lee's, right? Knowing Paul's answer is dependent on Lee's. So we see here the books borrowed by Lee. If he borrows 1, well, then Paul is going to borrow 6 more than that, and that's 7. 1 plus 6 is 7. And here, if Lee borrows 2, then Paul is going to borrow 2 plus 6, which is 8. And 3 plus 6 would be 9, so this one's done. 4 plus 6 would be 10. And 5 plus 6 would be 11. Okay, so we see that to find out what Paul borrowed, we need to know how many Lee borrowed. So we can write this as y equals x plus 6. All right, and x or Lee here is the independent variable. Lee is going on by his own happy self and borrowing books from the library. And Y, or Paul, is only borrowing books, looking at how many Lee has, and then saying, I can get more. So whatever Paul borrows is completely dependent on Lee's values. All right, I hope you see that. So that X is, or L, Lee is the independent operator here, and what Paul is doing, or Y, is the dependent variable. All right, well, let's go on to 8. At a craft store, Zoe bought some boxes of red beads and some boxes of blue beads. The number of boxes of red beads was 4 times the number of boxes of blue beads. So red beads is 4 times blue. And notice I'm not using an X for multiplication. I'm just putting the coefficient of 4 directly in front of my variable B in this case, all right, for the blue beads. And that means that I'm multiplying 4 times the number of boxes of blue beads. Okay, so my question is, which of these variables depends on the other? Which one needs the other? Well, red needs blue. In this case, R needs B. Why? Because we find out R only when we know how many boxes of blue beads there were. Then we multiply that by 4. Okay, so here we see if there are 2 boxes of blue beads, then there are 8 boxes of red beads, right? Because 2 times 4 is 8. Well, if there are 3 boxes of blue beads, then there are 12 boxes of red beads, because 3 times 4 is 12. And if there are 4 boxes of blue beads, well, 4 times 4 is 16, there will be 16 boxes of red beads. If there are 5 boxes of blue beads, 5 times 4 is 20. And the last one is done for us. If there are 6 boxes of blue beads, there are 24 red beads. Okay, which one is would be plotted on the x-axis, and which one would be plotted on the y? Well, B is going to be the independent variable, so it would get plotted on the x-axis, and R is the dependent variable. It would be plotted on the y-axis. All right, let me put independent here and dependent here. All right, very good. Well, on to the very last one. We're going to use the data points to plot the points in the coordinate plane, and we will see what kind of line we get. And then we're going to use an equation to show the relationship. Okay, so this one was plotted wrong. The previous one was labeled wrong, and this one is plotted wrong. So the time that it takes, in 1 hour we can travel 50 miles. So we need to, and we're told that the distance that we travel is d, and the time it takes is going to be t. All right, so this is distance equals 50t. Now, why is that the equation? Well, I see that if I travel 1, I get 50. If I travel 2, I get 100, which is 50 times 2. 3, 150, which is 50 times 3. 4 is 200, which is 50 times 4. 5 is 250, which is 250, which is 50 times 5, and 50 times 6 is 300. All right, so the distance, I'm multiplying 50 by the number of hours that is being traveled. All right, so this is my equation. Which one is the dependent variable and which one is the independent variable? Or, spoken a different way, which variable needs a value for the other in order to solve for it? Well, in this case, D needs T, right? We need to know how many hours that we're driving in order to find out how far we went. So if you drove 3 hours, then you would wind up driving 150 miles. That would be your distance, right? So distance depends on time traveled. And so D is the dependent variable, and T is the independent variable, and that means that when I order these pairs, I'm going to order them like this: 150 to 100 3, 150, 4, 200, oops, and so forth, right? That the t here in this case, or the time, is going to be my independent. And the distance is going to depend on however long it is that I drive, right? Okay, good. Well, let's go ahead and plot them, and let's use these plot marks. So 150, we go to 1 and then up to 50. So right there. In 2 hours, 2 times 50 is 100. And now we're at 3 hours. 3 times 50 is 150. 4 times 50, 200. 5 times 50, 250. And 6 times 50, 300. And so our plot marks look like that, and our linear line for this equation looks like that. All right. Well, I think that clears up pretty much most of the problems. If you have further questions, please by all means do ask. See you later.